Welcome to physics, the study of matter and energy. Physics is one of the many sciences that describes the world around us, like the motion our eyes see every day. Today, you're gonna learn all about the awesome laws of motion that the boss dude, Isaac Newton, came up with. Heck yeah! Before we get into any rad lectures, we gotta set this thing up right. Step 1, get a cool beans beat. Step 2, spontaneously change footage to daytime with absolutely no explanation. Step 3, you're ready to learn some physics. Meet my friend and music guy, Jake, Brad. Yes.
That's not my...
Thanks for being here, Brad. Today, Brad is going to help me demonstrate
Am I even being paid for this?
Newton's laws of motion.
Let me just narrate this, you airhead. Back in a good old year of 1687, Newton published Philosophiae Mathematical Principles of Natural Philosophy. This book, more commonly called Principia, which from this point I will refer to as P, informed the world of pretty much all the main aspects of physics, except energy. I guess you could say the scientific world really drank in all of the knowledge they could from Newton's P. Okay, I'm not actually going to do that, I'm sorry. But moving on, inside of Principia we have our 3 laws of motion. These laws basically describe all motion around us, and when combined with the other discoveries of Newton, as well as other scientists, we are suddenly able to do some pretty amazing things, like finding the mass of the whole Earth and even other planets.
Now wait, you aren't just going to loosely explain these Reaganomical laws and call it a day, are you? That'd be totally lame.
Of course not. Here, I'll explain the basics of these laws and provide a little demonstration. First law. Object at rest stays at rest, object in motion stays in motion. A brief synopsis of the first law is that an object at rest stays at rest, while an object in motion stays in motion at the same speed and direction, also called vector, unless acted on by an unbalanced force, a force from one side that overpowers the other. To demonstrate this law, I have a tennis ball.
Hey, that rhymed!
Shut up. Here's a tennis ball at rest. Got it? Good. And here's a tennis ball being tossed underhand. Notice the trajectory of the ball as it flies through the air. This is called a parabola, a mathematical curve determined by the velocity, angle, etc. that the ball is traveling, ending on the ground from gravity pulling it down. Remember that. Teacher's going to give you a quiz after this.
Oh crap.
Good luck. Next law. The second law in a nutshell is that acceleration is proportional to the force on the object. In other words, more or less force causes more or less acceleration.
That sounds pretty simple.
Even for you, huh? Anyways, if I were to toss this tennis ball again, you can observe the speed of the ball going through the air before finally landing on the ground. Now, if I toss the ball and put a little more strength into it, you'll see... Notice the ball traveled much faster as a result of me putting more force on it. Newton's third law states that all actions have an equal and opposite reaction. For example, these two objects being equally pushed to... Well, that's pretty much it in a nutshell.
You wanna go eat or something?
Okay.
Bye.